Okay guys, so what I want to do in this video is quickly run through one of our problems here just to show you how we can keep adding up forces from multiple charges. So in this example here, I have a square built up of 4 charges at the corners with 1 charge in the center, and we want to know what the net force on this charge will be, right? So you'll probably see this in your module for today's work. But what we're going to do here is we're going to look at the force from each, right? And then we're going to see how this changes if these are positive or negative, or what if we change one of the charges for a different magnitude. So getting started here, one thing you'll see maybe in the beginning is that maybe all my charges will be the same. So we can do this by showing something like QA, B, C, D, all of these are the same. Maybe we can say that these are all 2 microcoulombs, right? And just to review, remember that this micro means times 10 to the minus 6, right? So times 10 to the minus 6 for all 4 of these guys, right? So how would I find what the net force on this charge will be? Well, you see that if my Q in the middle is also 2 microcoulombs, then what I have is this is positive and this is positive, so they repel each other, right? So these two want to repel each other, so from this angle here, it'll be pushed this way. But C is also pushing back, so it'll be pushed this way here. D is also pushing on it, so it'll be pushed to the upper left corner, and then A is also pushing, so it'll be pushed towards D. All of these should cancel out because they should be the same distance from the center, and they are the same magnitude, right? So this part is easy. We can see that just by doing this, my net force should be 0, right? It should be 0, but we can actually find this by calculating, right? So what we need to do is find the force on each one of these using our formula, which is K here, Q1, Q2 over R squared, right? In this example right here, my Q2, we can just refer to this as Q, right? So this will be this Q here. And my Q1 is the only thing that is changing. This is A, B, C, or D, right? You can see right now all of these are going to be the same. And my R here is one thing that we haven't calculated yet. So let's go ahead and calculate that right now. Let's say that each side of my square is 10 centimeters. Okay, so if I say 10 centimeters, and this side right here is also 10 centimeters, okay, then what is the distance from the center of this square to any of the corners? What I have to do is I want to find the X and Y distance. So what I'm going to do is, let's say I want the distance to QA from Q. So I need some horizontal distance, right? And then I also need some vertical distance right here. And these two together, remember these two, when I put them together, they will give me my hypotenuse. All I need to do is Pythagorean theorem to find the distance from the center to the edge, right? So if we wanted to do this, we can find the X and the Y in order to find our hypotenuse. But if you see here, this is pretty easy. This is just half. It's half of my 10. You can see it's half of this square. So we can easily put this down here as 5 centimeters. And this also goes, let me go ahead and change this color right here. This also goes for our Y direction. This is also just half of my square, but since the whole thing is 10, half of it is 5. So 5 centimeters. So right now, all I need to do to find my hypotenuse is just going to be the square root. Oh, sorry. Right here, these are 5 centimeters. Remember, we also want to convert this to meters. So my 5 centimeters should be 0.05 meters, right? So be careful of that. So we want to do 0.05 squared plus 0.05 squared, and that should give me the value of my hypotenuse. So I'm going to go ahead and do this right now, this calculation. So we should have square root 0.05 squared, 0.05 squared. So we should get 0.0707. So I'm going to go ahead and put this as 0.071. Okay, this is equal to 0.071 meters. So this should be my value for R for all four of these throughout the entire problem, right? 0.071, that's fine. The only thing here is determining the directions of each force. So let's go ahead and let's draw this one more time right here. But what I want to do now, so I'm going to go ahead and leave this here, and let's draw this again. But I want to take out most of these values, most of these calculations, so that we have something clean to work with. So looking at this square again, what you guys need to do is find the direction of each of these forces. So let's say QA is going to put a force on Q, and to find the magnitude of this force, I'm going to call this A and just Q. Or you know what, I'll just call this force of A. Okay, now what we want to do is use our formula. This is K times QA times Q over 0.071 squared. Okay. So this is, I'm going to do the calculation here for everything except QA because we're actually going to need to be using that over and over. So I'm going to put this as QA, leave that capital, times, okay, doing my K, which is 9 times 10 to the 9, okay, times my 2 microcoulombs, which is 2 times 10 to the negative 6. And we're going to divide this by 0.071 squared. So we should get something like, this is a long number here, something like 3570720. All right. So this is 3,570,000, right? So what I'm going to do right now is I'm just going to replace this. We want to keep this nice and clean with 3.57 times 10 to the 6, okay? So remember, we always want to, for these large numbers, small numbers, we want to change them into scientific notation. So this should give you this, and then now all I can do is change my charges. That way, if, let's say, we change B to 4 microcoulombs and C to 3 microcoulombs, well, all we have to do is change this value right here, okay? Now, in terms of the actual direction of the force, well, here, what we need to do is we need to find this angle, okay? Let me find an angle here. Or let's go and do this up on our notes triangle. This angle right here, but we know this angle is just 45 degrees, okay? So whatever force I get from this is going to be, so let's say, okay, let's go ahead and multiply this out to kind of give us a number. This will be times 2 times 10 to the negative 6. So what I should have here, my force from A should be 7.14, okay, newtons. And the direction, so I'm going to put this as at my direction, this is going to be, I'm going to put negative 45 degrees. I put this negative here because it should be below the horizontal. Okay, so doing this in here, you guys can convert this back into x and y. It should be something in the x and something in the y. So if I draw my triangle again, but this is a slightly different triangle now because it's force. So it's still coming from QA to Q, right? I want to know what is the x component and what is the y component. I have to get this vector and decompose it, just like you would for forces in 1401, right, in your College Physics 1 course. So what we have to do, this time I'm starting with 7.14 newtons is my hypotenuse, and my angle is 45 degrees. So what is my y component and what is my x component? Just keep in mind that it is pointing in this direction. So I'll have something that is negative for the y, pointing down, and then positive for x, pointing to the right. So when we do this, we can use our formula. Let's go ahead and put this as theta is, let's go ahead and use, I need to use my hypotenuse here. So we're going to use sine and cosine. So I have sine 45 degrees is equal to my opposite, which is this right here. So my y over 7.14. And then I should have cosine of 45 is equal to x over 7.14. But just so you know, these two things are going to be the same. Sine 45 and cosine 45 are going to be the same. So actually, both of my x and y values should be the same thing. And if we calculate this out, it should be 5.05, about 5.05. So my force here, we're going to call this force from A in the x direction is going to be 5.05 newtons. Positive, right? Positive because it's to the right. And then we have force from A in the y direction is going to be 5.05 newtons. But this is going to be downwards. This is going to be negative, remember, because it's pointing down. Okay, it's pushing down and to the right. Okay, so don't forget these two things here. Now this looks like a ton of work just for one. So it looks like you're going to have to do this again for B and D and C. But actually this isn't the case, right? Because every time you do this, it's going to be the same angle. It's going to be the same radius. Everything is going to be the same. Even the charges in our examples that you guys are going to work through are going to be the same. The only thing that's going to be different is where you put these pluses and minuses. If it's down, remember that my y is negative. If it's to the left, remember that my x is negative. And that's it. We're just going to be working through these four. So you'll always be using these numbers, just changing the plus and minus signs.